Okay, so question 19. The context is there's a proton has an initial speed of 4 10 to the 5 meters per second. What potential difference must the proton move through to reduce the initial speed by a factor of 2? So this is very similar to question 18. So again, stating that, again, considering the field that's creating this potential difference, and the proton is an isolated system, so it says delta V is delta U divided by Q is negative delta K divided by Q. So we're looking for the delta V that reduces the kinetic energy by a factor of 2. So our delta V, in this case we have negative, that comes from the negative sign here, of 1/2 of m times V final squared minus V initial squared, all divided by Q. In this particular case, the final speed will be half of the initial speed. So delta V is going to be negative, again, 1/2 of m times V initial over 2, all to be squared, so don't forget the all to be squared there, times the VI squared, all divided by Q. So this final speed would basically be 2 by 10 to the 5 meters per second. If you want to do a little more algebra, you can. Just to isolate some of the terms. So you're going to have the negative here. This will be VI squared divided by 4. So I end up in a sense with 1/4 VI squared minus VI squared. So I have 1/2 of m times negative 3/4 VI all to be squared divided by Q. And then if you want to do a little bit more, you could of course combine the we'd have 3/8. So considering all of our algebra, the negative signs will go away, so we'll end up with having 3/8 of the mass times that initial speed squared, all divided by Q. I believe that should give you 626 volts. So going to sort of the nearest answer here, this is about 630 volts, approximately 600 volts for this particular question. So I choose choice B. And if you wanted to consider, in a sense, sort of a diagram here, we could consider a uniform field. That doesn't have to be if it's, but you could think of a sort of a diagram where we have a uniform electric field creating, pointing to the right here, and if we have the proton, if we want to get the proton to slow down, we would fire it here. We would fire it in the opposite direction to the field. So this will be VI. And if at some point later it's moving with the speed of VI divided by 2, and the electric potential difference between these 2 points here, between these 2 equipotential lines, this delta V would be approximately 600 volts, where at this point on the left is at 600 volts higher in potential than the